So g of x is defined as the integral. So to find g of negative 1, that's the integral from negative 4 to negative 1 of f of t dt. And the integral for f is just the area in the curve. Notice the area is below the x-axis, so that's going to be a negative. So we've got 1/2 base 1 plus base 2 times the height, the area of the trapezoid, but don't forget the negative. So g of negative 1 is going to be negative 15 over 2. To get g prime of x, we got to take the derivative with respect to x of the integral from negative 4 to x of f of t dt. Following the fundamental theorem of calculus, x gets replaced in, so g prime of x is f of x. So g prime of negative 1 is f of negative 1. From the graph, f of negative 1 is at negative 2, so g prime of negative 1 is negative 2. Then to get g double prime of x, just take the derivative of f of x. So g double prime at negative 1 is f prime of negative 1. And f prime is the slope at f at negative 1, which you can see is a sharp turn. So g double prime at negative 1 does not exist because f is not differentiable at x is equal to negative 1. Get a point of inflection on the graph of g. That's going to be when g double prime changes signs. So g double prime is equal to f prime of x. So to look at a g double prime number line, that's when f is increasing and then f is decreasing, so g double prime is positive and then negative. So g has an inflection point at x is equal to 1 because g double prime changes signs at x is equal to 1. So to find out when h of x is equal to 0, just take h of x as equal to 0. That means we're thinking about when is the area going to come out to 0. So the area is going to be 0 when we're at the number 1. The area is going to be 0 when we're at negative 1. And at x is equal to 3, because the integral from 3 to 3 would be 0. To find when h is going to be decreasing, we've got to look at when h prime is going to be negative. So to get h prime of x, we're going to take h of x, which is that integral from x to 3 of f of t dt. And then to take the derivative of h of x, let's go ahead and flip the interval of the integral. So that's going to be negative integral from 3 to x of f of t dt. So now to take the derivative of h of x, it's the opposite of the derivative of the integral from 3 to x of f of t dt. So that's going to be negative f of x. So h prime of x is going to be the opposite of f of x. So for h prime, it's the opposite. Since f is negative, that's going to be positive. And then f is positive, so that's going to be negative for h prime. And then negative for f, so then positive for h prime. So h is decreasing on the interval from 0 to 2 because h prime is negative on that interval from 0 to 2.